let's see if this is actually going to work. I hope it does. So I'm going to try to record this. Hopefully my voice lasts. Apparently it's giving away. Yelling at too many jumpers, apparently. Anyway, let's get going with the final review. I think this is all that I'm going to sign for review. Not all, but that, it's going to be a good review for you. So let's talk about stratified sampling. Let's talk about stratified sampling. Stratified sampling is when you break things up into groups. So you group things. So what you're looking for, if I'm talking about stratified sampling, it's like you're comparing one group with another group. Like, how did the freshmen compare to the seniors? How do the teenagers compare to the 20s, compare to the 30-year-olds? That's stratified sampling. Convenience sampling is just you ask your friends. Ask your friends. I'm not going to ask you about anything about convenience sampling, only because it's so dumb. I'm going to try to get a bigger screen here. All right. Systematic sampling. Now, this one's going to be kind of a big one. Systematic sampling is simply, I think the thing behind me is flashing for some reason. Systematic sampling is when you, let's say, I'm going to ask the 31st person that comes through the door. So I ask the 31st person that comes through the door. And then after that, I'm going to ask every 9th person. That would be a systematic sample, where you come up with some kind of system, that you can randomly select people. Now, don't forget, if the 31st person won't answer you, then you got to go to the 32nd. But that's kind of systematic sampling. All right, response bias. Response bias is changing your answer I haven't written on this with this tablet in a long time. Plus, I've been outside working all day. My hands are dead. Changing your answer based on the conditions. So, that's when I freaked you all out and I said, hey, do you smoke or do you vape? If I'm asking you, you might even if you did, you'd be like, no, of course I don't. Whatever random answer. If you're going to change your answer based on the person that's asking it or the conditions that it's being asked, then that's response bias. Non-response bias means you sent out questionnaires or surveys and only received a few back. If you send out 50,000, surveys and you only get 8 back or 10 back or 100 back, that means you didn't receive responses from the vast majority of people. So that would be a kind of a simple example of a non-response bias. Voluntary response bias is nobody asked you. Nobody asked you for your opinion. And that's the trick to non-response or a voluntary response bias. Nobody asked for your opinion. You're sitting at dinner time and you got a great meal. And you go up to the manager and say, I had a great meal, the cook was amazing. Okay, that's voluntary response bias. Nobody really asked you for your opinion, you just kind of gave it. Now, I'm not saying it's wrong, but it's voluntary response bias. And again, most people that are voluntary response bias are having negative answers. So if you just hear from those negative people, or if you're in a store and you're like, hey, great service, and you walk up to the manager, hey, great service, Bob over there was amazing. That's voluntary response bias. Undercoverage bias is systematically leaving out a group. Systematically leaving out a group. So, whatever. Sorry, my hands barely move right now. So you go and you say, I want to know what kids in the building think about having a pep rally on this weekend. And we ask everybody but the freshmen. Well, that would be under coverage bias. It would be all right because, nobody cares about them freshmen anyway. Just kidding. But that would be under coverage bias. If you systematically somehow leave out a group. A lot of people do this to kind of get their answers or results that they're looking for. All right, I'm going to see if this is recording. All right, looks like it's working. Voice is back. All right, so apparently this is the number taken average of 10 values. Oh, use the number table to take the average of 10 values. So I'm sorry, I misread my own problem. So we're going to take the average. So apparently these must be like the weights of 100 people. So these are the weights of 100 people. So notice they go from 0, 1, and if you remember correctly, this one right here we're going to use as 0, 0. We're not going to use 100, so we won't use that. Now I'll tell you where to start, but in this case, we're going to start right here. I'll be like, all right, I want you to start right here. This is where a random number table came from. So I'll go to 41, and I'll highlight 41. Then I'll go to 85, and I'll highlight 85. Sorry, not burping. Then I'll go to 99, and highlight 99. Let me get rid of that. And then I'm going to go to 41. I'll highlight 41. Oh, wait. I already had a 41. So I got to get rid of that one. I can't do that one again. So this is 1, 2, 3. Can't do 41. I go to 98. 37. So you got to remember that if you get a repeater, you got to skip it. 18. 26. 13. 45. I got to keep track of how many I got. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 88 would be number 10 apparently. And I'll triple check that. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, had I arrived at a 0, 0, I don't really see one here. Here's one right here. Had I arrived at a 0, 0, I would be using 100. But I didn't get a 0, 0, so I don't have to use number 100. All right, so now all I'm going to do is take those numbers, whatever those numbers are, the weights of individuals. I'm going to write them down here. So that's 100 plus 157 plus 196 plus 101 plus 61. 61. That's one light kid. 188. I mean, I don't know where that number came from. Plus 194. Must have been like an elementary school kid or something. Plus 190. Plus 182. Plus 187. And then whatever that number is, I'll divide by 10. So let me get my calculator up. Put that over here on calculator mode. I'm just going to add those up. 100 plus 157 plus 196 plus 101 plus 61 plus 188 plus 199. Oops, I think that was 194. Plus 190 plus 182 plus 187. Enter. And then I'll probably write that down, what that is, 1556. So 1556 divided by 10, obviously, is 155.6. So simple random number generator, random number table, how to pick values out of it. Key things is don't you got to get rid of repeaters, and the number 100 is 0, 0. Other than that, it's fairly easy. Be careful. So we're going to go through skewed left and skewed right. And then we're going to go some other stuff. So, or symmetric. So this one, why is this? I don't like this. What would this one look like? Oh, God, that's terrible. All right. So this one right here is symmetric. And this one right here would be symmetric. And this one right here would probably be symmetric. Or just weird. I would never give you one like this. It's too vague. If I drew the curve on this, notice how it tails off this way. That means it's skewed left. This one over here is skewed right. Now let me make sure what I'm asking down here. All right, let's go through real quick. Let's say for fun, I wanted to put the mean and median on here. Well, in this case, the mean and median would be right here. Whenever it's symmetric, the mean and the median are about in the same place. So the mean is approximately equal to the median. Over here, the mean would be approximately equal to the median. It's only when you get to the skewness ones where it's a little bit different. Remember, if you have a low score down here, then the mean is going to go this way. So in this case, the mean would be less than the median. In other words, the mean follows the tail as the skewness follows the tail. On this one, the mean will get pulled up here. So in this case, the mean is greater than the median. So that's how we're going to answer these questions. If I told you that the mean and the median, so the mean is approximately equal to the median, then this is symmetric. If I told you that the mean was greater than the median, therefore the mean got pulled up greater than, so it's going to the right, so this is skewed right. If the mean is less than the median, then that means the mean's getting pulled down, so that's skewed left. All right, we're back. All right. If the mean is 48.5 and the standard deviation is 3.3, according to the empirical rule, what percent would be between 45 and this? So, or 42.5. So remember, the empirical rule is simply just 1, 2, 3 standard deviations. God, that's hard to write. I don't know why it picks up such an obnoxious number. 48.5, and the standard deviation is 3.3. So if I take my calculator, and I take it, let me just shrink this up a little bit, and I subtract 45.8, is that really what I want? And I subtract 3.3, I get 42.5. So 42.5 would be right here. And if I add that, I'm probably going to get 49.1. Well, because I went up and down one standard deviation, that's 68.2%. And then this one's just going to be down 2 standard deviations. So 39.2 would be here, and this would be up here, 52.4. So it's 2 standard deviations. We remember 95.4%. Sometimes in New York State, because they're dumb, 99. And then again, this one right here is just going to be down 3 standard deviations, 35.9 and 55.7, and that's 99.7. So 1 standard deviation, 2 standard deviations, 3 standard deviations. I think there's one question on that. All right. We have 2,500 cars on our dealer. Every month they record the number of miles driven. The average number of miles driven is 82 with a standard deviation of 68. Now, somewhere in here I should have said that these were normally distributed. Otherwise, you can't really draw the normal distribution curve. Apparently, I can't draw it either. 82. So let's assume I pretend I said that to you. Standard deviation is 6.8. It says, what is the probability a charge chosen at random is 91 or more? So 91 would be right here. 91 or more would be in this direction. All right, sorry, a little pause there. Okay, I needed a z-score table. I don't have one in here. So anyway, here we go. So we're going to find the z-score. So we're going to take z equals the observed, which is 91. It's on the right, so we should have a positive z-score, minus 82 divided by 6.8. And we're just going to figure out what that number is. So control division, 91 minus 82 divided by 6.8, and we get 1.32. So 1.32. So the probability that z is greater than or equal to 1.32 equals. Now remember, this notation is just bonus. If you just come over to the z-score table and you take a look at it and you say, okay, I need, sorry, I'm trying to get, there we go, 1.32. So 1.3012, 0.0934, so 0.0934. So come back to the tail, 0.0934, that's what I want, so 0.0934. Done. The top 15% the top 15% of cars driven must be sold in the next week. How many cars must be sold? So this case a little bit different. Top 15%, this is 82, standard deviation of 6.8. But now I want the top 15%, so that's whatever. That's right here. So the top 15%, that make this 0.1500. So now I got to go play Where's Waldo. I don't know why I'm doing that. Now I'm going to go play Where's Waldo, 0.1500. So it's somewhere in between these two, but it's closer to it's closer to this one. It's actually closer to this one, so I'm going to use this number, 0.14. So my z-score is negative, or it's 1.04. 1.04. So I get a z-score that's equal to 1.04. All right, so now I go, okay, God bless it. 1.04 is equal to x minus 82 divided by 6.8. Man, this pen does not allow me to work very well in here. So I'm going to take my calculator. I'm going to go 1.04 times 6.8. Oops, not going to be able to guess anything. 1.04 times 6.8, and I get 7.70. So 7.07 is equal to x minus 82. I'll add 82 to both sides, and I get 89.07. So 89.07. So it looks like we got to sell 89 cars. I don't know. Oh, wait. Oh, no. Wait, hold on a second. All right, so I need a better picture for this. Let me draw a better picture. So here's 22,500. And a standard deviation of 4,200. Why do I pick numbers with 4 when I know that my pen is terrible with 4s? All right. Now, I want from above average, which is this one right here, 23,800 to 26,000. So this one's a little bit tricky. We got to do 2 z-scores, so I'm going to do both z-scores. So 23,800 minus 26,000, no, minus 22,500 all over 4,200. So control division, 23,800 minus 22,500 all over 4,200 equals 0.31. It's a z-score 0.31. Then I'm going to do the next one, which is 26,000 minus 22,500 all over 4,200. .833 or 0.83. So now I go back to my z-score table. It's going to get a little funky. First one I'm going to look up is 0.31. So 0.31 is 37.83. So 37.83 is all this. 0.3783. Then I'm going to look up 0.83. 0.83, 0.0123 is right here. 20.2033. So from here over would be 0.2033. So to find the part in the middle, I just subtract those. So I take 3783 and I subtract off 2033. So 0.3783 minus 0.2033. I get point one, so 17.5%. I get 0.175. So 17.5% of these people are above. So if there's 150,000 people doing it, I take that and I multiply by 150, 1, 2, 3, and I say 26,250 are above average. All right, the bottom 12% are kicked off the game and put back into training. The next 18% are warned. All right, so the bottom 12% are kicked off. The next 18%, so that puts us up to 18% are warned. The next 20%, so that's 30, the next 20%, that put us right here, are safe but not doing well. And the rest get to play without any warnings. How many of the players are either kicked off or warned? How many are kicked off or warned? Well, that makes the bottom 30%. So 18% or 12% are kicked off or warned. That makes this 0.300. Makes the bottom 30%. So the bottom 30% get kicked off or warned. So, so again, this is a bad question. It should say what score puts you in the bottom. What score would put you in the bottom for? I'll change this. So the one you're going to have is probably going to say what score lands you in this range. Something like that. I'll change the wording so it says it. So we're going to look for 30%. In other words, we got to go play Where's Waldo. Oops. So we're going to go play Where's Waldo. Go down to Z-score. We're looking for 0.30 again. We already found that one time. 0.30. That was this one right here. So that's a Z-score of negative 0.52. Why is it negative? Because we're on the left side now. So I need a Z-score of negative 0.52. So I go, all right, negative 0.52 equals x minus 22,500 over 4,200. If I come back to my calculator, I go, all right, negative 0.52 times 4,200 equals, so negative 2184 equals x minus 22,500. And then I'll just add 22,500. And I get a score of 20,316. So if you get a score of 20,316 or lower, you're going to get warned or kicked off. And the final one says, what percent of people are considered superior? All right, this is the easiest of the three questions. What percent is superior? So 22,500. 20, what was superior? 26,000? 26,000 is superior. So what percent are superior? Well, these people are superior. So we just run the z-score. Z equals 26,000 minus 22,500 all over 4,200. 26,123 minus 22,500. Oops. All over 4,200. And I get a z-score of 0.83. So come back to the z-score table. 0.8, here's 0.8, and then there's 0, 1, 2, oh, here it goes, 20.33. So 0.2033. So what percent? About 20%, 20.3%. All right, so here we go. We're going to work on this. We're going to create a box plot. So I just took the time to put those numbers in my calculator, which should be right about here. All right, I got those numbers in my calculator. First thing I'm going to do is run the 411 on it. So I put them all in, make sure they're accurate, and then I go menu 411. One list, I called it X, I click OK. Now, here's my average. So I'm going to put all my information in here. Oops. So I get X bar equals 255.6. 255.6. My sample standard deviation is 17.5. Now I'm going to go my 5-number summary, right? We're going to go min, Q1, median, Q3, and max. 203, 245, so 203, 245, 256.5. Oh, I've already done this one. 269. Well, maybe I haven't. I don't even know. 279. All right, box plot. So first thing I'm going to do is create a line. And I'm going to put an equal scale. 200, 210, 220, 230, 240, 250, 260, 270, 280. That's all I got to go. 210, 220, 230, 240, 250, 260, 270, 280. I'll do the box first. 245, 269. If this is a repeat, I'll have to find another one maybe to do, or you can just do this one again. 256.5, go up, down. Oh yeah, this is definitely a repeat. Number of hours driving in toll booth. I guess this is good practice. I'm just going to go back through it again. Not everybody saw this, so I'm just going to go through it again. So that's that. That's easy. And then I'm going to come down here. I'm going to create a histogram. This is fairly straightforward. Do his and 1. I think go 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right. 210. Nope. 200 to 201 to 210. Let's see if I can write even smaller. $211 to $220, $221 to $230, $231 to $240, $241, Jesus, to $250, $251 to $260, $261 to $270. There'll be another one of these. $271 to $280, and $281 to $290. That should say 90. Then I'm going to go through and figure out how many are in each. So first one has 1. This one has 2. So 1 and 2. 30 to 40. 4. 50 to 51, or 41 to 50. That's 5. 51 to 60. Careful with this one. Oops. So I got 1, 2, 3, 4, 5, 6, 7, 8 in this one. This one has 9, I think. Yeah. And then how many between 71 and 80? Oh, I don't even need that one. The last one has 2, 3, 4, 5, 6, 7. Last one has 7. I don't even need the last column. So the highest I got to get to is 9. So I'm going to make every 2 boxes 1, 2, 4, 6. How did I forget 3, 4, 5, 6, 7, 8, 9. So we'll go up to 1. Sorry, this is going to be impossible. This is 1. 2 bars come off each other. Yours will look a lot neater than this. I absolutely cannot draw straight lines with a ruler with this thing. It's ridiculous. This one is 5. There's just no way to do it. 8. Man, it looks like my goodness. Those should be straight lines. 9. Do not go off the top of the graph. And then 7. Now, I forgot to do 2 things up here, and it's because I didn't give you any space, but I promise I'll give you space on the test. The other 2 things you need are IQR, which is Q3 minus Q1. So IQR in this case is from 269 to 240, from 269 to 245. 269 to 245. So 269 minus 245. So my IQR, if you want to do it on the calculator, you can always do this. Going home, I'm just going to show this to you. Come over here, home calculator, 269 minus 245, and you get 24, obviously. So remember, my low range is going to be Q1, which is 245, minus 1.5 times 24. And then my high range, this is for outliers, is going to be 269 plus 1.5 times 24. So 245 1.5 minus 1.5 times 24, and 269 plus 1.5 times 24. So 209 and 305. So 209 and 305.5. So anything lower than 209, anything higher than 305 is an outlier. Oh, that's one thing we did not do on this one, is the description. So anything lower than 209. So it looks like this one is the lone outlier. All right, so we're going to go through the four things. SOX. We did not do this on the review because we hadn't learned this yet. So the shape of the distribution is skewed left. Hopefully you see that it tails off to the left, even with my crappy drawing. Shape. The center of the distribution as represented by the median is 252. I forgot actually. You can always go back and look. 256.5. I can't read my own writing. Is 256.5. Boom. Center. The spread of the distribution as represented by the IQR is 24. That should be a 4. If there were any outliers, they would be less than 209 or greater than 305.5. .203 is an outlier. You could write therefore 203 is an outlier, and then just put it in one sentence. Boom, done. All right, there we go. All right, here we go again. So, last few questions. Sam has been researching Major League Soccer goalie statistics, found that the average goals against was 2.33 with a standard deviation of 0.205. And again, I should be telling you in here that they're normally distributed. It will be like that on the test. So 2.33 with a standard deviation of 0.205. So, in order to be considered for the women's national, a goalie must score in the top 8.5%. So that, first of all, is 0.0085. I need to score in the top 8.4%, 5%. So how many goals against, what must my goals against average be? Well, the one thing you got to remember is this is going to be the better goalies down here, and this is going to be the worst goalies, right? Because if you let in more goals, you're bad, and if you don't let in very many goals, you're good. So the good goalies are going to be down here. So apparently Sam wants whatever her goals average to be down here in the top 8.5%. I don't know what I wrote that. It's 0.085. Guys, I'm really tired right now, so I'm hoping this all makes sense. I will definitely be coming on, I guess, Monday night or whatever, or Tuesday night to try to help out. So this is 0.085. So I'm going to go over my Z-score table. I'm going to go play Where's Waldo, because anytime I give you the percentage, then you got to play Where's Waldo. So 0.085 0.05. So right here is 0.0853. So that's negative 1.37. Now I definitely want negative because I'm on the left side. So I know my z-score over here has to be negative 1.37. All right, so do a little bit of math. Negative 1.37 equals, what does she have to get minus the average, which is 2.33, divided by the standard deviation, which is 0.205. So we're just going to cross multiply. Come over to the dumb machine. Hello, dumb machine. I'm going to type in negative 1.37 times 0.205. Bam. Negative 0.28085 has to equal x minus 2.33. So then I'll add 2.33 and I get 2.049. So 2.049 equals x. Rounding the nearest hundredth of a goal, x has to be equal to 2.05. You just got to be careful, right? If that number was bigger than 2.33, that means you're letting more goals in, and that's not good. All right, so Matt and Logan are having a heated debate on who's the best attacker on their respective teams. Doing a little battle of sexes, by the way. Logan is a girl, Matt is a boy. I think this was Mojay and Logan. I don't remember. Okay, I'm losing my mind. So if we randomly check a girl for the girls' team, the average is 12.6 with a standard deviation of 2.2. So this will be for Logan because that's the girl. So the average is 12.6 with a standard deviation of 2.2. And the boys, which will be Matt, the average is 8.6 with a standard deviation of 1.9. Now, Logan told Matt that she averages 15.2 shots. So she averages 15.2 shots on goal. What does Matt need to get in order to get the same thing? Well, these are two different distributions. So literally all we got to do is just check their z-scores. So let's do Logan's z-score. Z equals observed, which is 15.2, minus average, which is 12.6, divided by 2.2. And she gets 1 point, so her z-score is 1.18182. Do not round this one. Matt's got to get the same one. Well, what is the minimum number of shots on goal he has to get rounded to the nearest tenth? Let's just round it to get the same amount. All right. So I'll tell you the technical answer to this question, but this kind of question I would take either one. So he needs to get the same z-score. So his z-score has to be 1.18. So he has to get a z-score of 1.18182 equals his observed value, which we don't know, minus 8.6 divided by 1.9. So come over here. We're going to say times 1.9, 2.24545 equals x minus 8.6. Add 8.6, and I get 10.8. So 10.8 equals x. That's rounded to the nearest tenth. Now, this would be totally fine, but the actual answer to this question will be 10.9. Because 10.8, they'd have the same amount. 10.9, he would be better, or approximately the same amount. All right, done with that question. The Dilbert Donut Delight Company has been glazing donuts from the Kidder Corporation 10 years. He tells the donut company, the donuts averaged 28 grams with a standard deviation of 1.9. Ms. Kitters told him she's going to inspect the next shipment of 1,500 donuts, and anything less than 24.5 grams is going back. All right. Should have said it was normally distributed again. 28, standard deviation of 1.9. So she's rejecting anything lower than 24.5. So anything down here she's rejecting. So I'm going to run the z-score. Z equals 24.5 minus 28. Notice this is going to give us a negative value, and we're on the left side, so that should be negative, divided by 1.9. Control division, 24.5 minus 28 divided by 1.9. And we get negative 1.84. So my z-score equals negative 1.84. So go over to the z-score table, negative 1.80, 1, 2, 0, 1, 2, 3, 4. So 0.329. So 0.0329. So that's what we want. But that's not the question. The question is how many donuts. So we're just going to take 1,500 and multiply by 0.0329. And I get 49.35. 49.35. So they're going to reject approximately 49 of these donuts. A freshman friend of mine took a level 1 calculus course at a very large university, claimed over the journey for students so they could way of grading. The latest semester, the students' grades were approximately normal, driven with an average grade of 84.5 and a standard deviation of 5.4. How many of these students received a B+? I got lots of room on this one, so I can draw this thing up. It's going to be a little more interesting. So 84.5. B+ is from 91. Oops, standard deviation of 5.4. So I want to go from 91 to 94. Now I don't really care where you put those, but it's in between here. So if you remember correctly, this is the one where we're going to find this one. We're going to find this one, and then we just want the part that's in the middle, so we're just going to subtract. So I got to run two z-scores. So z equals 91 minus 84.5 divided by 5.4. And z equals 94 minus 84.5 divided by 5.4. So 91 minus 84.5 divided by 5.4. And I get 1.20. And then if I do that same thing, but now with 94, I get 1.76. So I'm going to look up those z-scores and see what those percentages are. So 1.20, right? 1.20. So 1.20, 11.1151. So this one is 0.1151. Now we got to do 94 above, which is 1.76. 1.70, 1, 2, 3, 4, 5, 6. 0.0392. 0.0392. So if I just take those two and subtract them, and so again, here's the bonus, probability that 1.2 is less than z, or less than or equal to z, is less than or equal to 1.76. This is going to be equal to 0.1151 minus 0.0392. 0.1151 minus 0.0392. Bam. 0.0759. 0.0759. 59. Now I got to be careful. The question is what percent or how many? In this case, it says how many. So there's 350 students. So I got to say, okay, I got to multiply this by 350. So times 350. 26.56. So 26.56. So approximately 27 students. Dr. Dufed knows that the dental insurance companies, not very good, decided to charge people based on their level of income. The top 9% will pay full price. The next 25% would pay 75% of the bill. The next 22%, so this is 75% of the bill. This is full. The next 22% would have to pay half the bill, 50%. The next 29% would have to pay 25% of their bill. And the bottom 15% would have to pay 0%. So, if the average household incomes are approximately normally distributed, with a mean of 8,200, I was going to say that's a really low average, 65,000, with a standard deviation of 8,200. What household would require a person to pay full price? Okay, so I want to know, what do you need for an income to pay full price? Well, full price is the top 9%. So because I gave you a percentage, we get to go play Where's Waldo. So we got to go find 9%. So that's like 0.09. Well, right here we go, 0.09. Closest. 1.34. 1.34. And since it's on the right, that's going to give me a z-score of 1.34. So I just run the z-score formula. X minus 65,000 divided by 8,200. So I'm going to cross multiply. So I come over to the dumb machine. 1.34 times 8,200. 10,989. 10,988 equals X minus 65,000. And then I'll add in the 65,000, and I get $75,988. So a person has to make $75,988 in order to be in that top 9%, in order to pay full amount. So what income would pay less than half? Well, the people that are less than half are these people. So that's that 29% plus the 15%, which would put us at 44%. So the bottom 44%, So if I'm looking at this picture, 65,000, 8,200. I'm looking at this bottom 44%. So now what do I need to be in order to be in the bottom 44%? So go play Where's Waldo. Got to go look up 0.44. Let's see. Here's 0.4404. 0.44. Now it's close to 50%, so we got negative, because we're on the left side, negative 0.105. Negative 0.15. So this z-score right here is negative 0.15. So I'm like, all right, negative 0.15 equals X minus 65,000. Now 44%, that's close to 65,000. That's close to halfway. So it should be getting something close to 65,000, 8,200. So Negative 0.15 times 8,200. So negative 1,230 equals x minus 65,000. Add the 65,000, and I get $63,700. So if you make $63,700 or less, then you're going to pay less than half your bill. All right, last one of these, and this will, I guess, be the last review question. I already put this in my calculator. This is 60 people. Wow, that's psychotic. I would never ask you to do that. Oh, I haven't even put it in my calculator yet. Hold on. So Dr. Solo has been looking for income levels in families in Western Europe. Below is a list of the number of incomes in thousands of 60 randomly. So this is 25,500, 42,000, so on and so forth. So notice what I've done here. I've given you an area to do to show me all of your work, and I'll expect to see that. So after you type in all 60 numbers, again, I won't do that crap on the test, but so after you've typed them in, come to this first cell right here and do menu 411, one list. You called it X. Click OK. All right. Now we're going to write this down. Our X bar is, I'll get off my screen. My X bar is 50.875. $50.875. So that's 50,850. Standard sample standard deviation is 10.892. Now I'm going to do min to max. Min, Q1, median, Q3, and max. All right. The min, 1, 2, 3, 4, right there, 25.5. Q1, 44.25. Median, 52.05. Q3, 58.81. 58.81. Next thing you got to find is IQR, which is going to be 58 minus 44.25. Let me show you something again. I can come over here, hit the home button, click on this, and notice we'll have two tabs. You still haven't lost all your data, and you got all your other data here. So I'll go 58 minus 44.25. My IQR is 13.75. Now I'm going to do my work for my outliers. So that's 44.25 minus 1.5 times 13.75. $23.625. And then I'm going to take 58 and I'm going to add 1.5 times 13.75. Oops. Plus 1.5 times 13.75. And I get 78.625. So 78.625. So at this point right now, I'm going to come up here and go outlier. Not an outlier. So the only outliers is 81. So when I'm done, I'm going to have to remind myself that that's my outlier. All right, let's get a box plot. Now remember, the box plot comes from your 5-number summary. So I'm going to draw a nice straight line. All right, whatever. All right, and let's see. Our lowest is 25, our highest is 81. So I'm going to just go over here and I'm going to go, okay. 20, 30, 40, 50, 60, 70, 80, 90. Now the box for the box plot comes from these three. So 44.25. 44.25 would be somewhere around here. 58 would be, Jesus, man. 58 would be somewhere around here. There's your box. The median was 52.05, so 52.05. Turns out it's about in the middle. My max is 81, and my min is 25.5. Now you gave it a title, Income Levels in New York State. Income levels in New York State. Boom, done. All right, now we're going to do a box plot or a histogram. We're going to use bar widths of $5,000. All right, so 0, 0, break. Let's see. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Ooh. That would be kind of problematic. Oh, wait, hold on. We're going to start at 25. So 25 to 30, 35 to 40, 45 to 50, 55 to 60, 65 to 70, 75 to 80, 85 to... Wait. 25 to 30, 30 to 35, I don't know. I should probably pause this. My brain's just not. Well, if this works, we'll see. I'm going to go every 3. I hope it works. Fast forward to see if it works before you get started on this one. So 26 to 30, 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, 56 to 60, 61 to 65, it's not 65. What's the next one? 70, 66 to 70. Yeah, it's not going to work. God bless it. All right, the heck with this. I'm hoping on your sheet it says 10,000. We're just going to do 10,000 because I don't want to do that many bars. I'll be here all day. So we're going to put a break in here. So I'll go 21 to 30. 31 to 40. 41 to 50. 51 to 60. Oh, I hope I have enough this time. 61 to 70. I think I am. 71 to 80. And then 81 to 90. I don't know why I picked bar width of 5,000. That's just crazy. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Okay, good. All right, now I got to figure out what their frequency is. So I'm going to come over. Is this thing in order? Oh yeah. So what's the first one? You can fast forward if you want, just to kind of get the numbers down here. But what I'm going to do is going to go 25 to 30. There's 3 there. So 3. 31 to 40. 1, 2, 3, 4, 5, 6, 7. And then 41 to 50. I think that's 10. 11, 12, 13, 14, 15, 16. And then 1, 2, 3, 4, 5, 6, 7, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Jesus. I think that's probably why I picked 25 in this one. This is not going to be out pretty. 1, 2, 3, 4, 5, 6, 7, 8 in this one. This is going to be ugly. 8, and then there's 1 over here. All right, so I got to get up to 25. Let me see how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19. There's probably 20. All right, so every box is going to be 1. So this is 4, 8. Every box is 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 24, 26. And here we go again. Oops, didn't go all the way over. And then 7. This looks like heck. 16. I don't know why I'm using this color. I don't know why that pen's so skinny. I swear I haven't had anything to drink other than water. Oh, and a Coke. 51 to 60, this is the 25, so that's going to be up here. Well, this should be 28. 24, 25 should be right here, I think. Ooh, that was close. And then 8. And then 1. And this is income levels in New York State. All right, so now we're going to describe it. I would say this is fairly skewed left. I'd say this is slightly skewed left or fairly skewed left. So the shape of the distribution, remember SOCS, S-O-C-S. The shape of the distribution is skewed left. Oh, shape's done. Center. The center of the distribution as represented by the median is, totally forgot, 52.05. So we took care of the center. Center's gone. Spread. The spread of the distribution as represented by the IQR is 13.75, I believe. And finally, the last sentence. If there were any outliers, they would be less than 23.625, 23.625, or greater than 78.625. comma, therefore 81 is an outlier. Boom. All right, I'm going to go over a little bit of, all right, so this is a fairly simple question, I think. 180. So 180 is one of the crazy ones, right? So if I was just doing 180, I might just use my calculator, see if that comes out to be giving me the right nice answer. Secant 180. Oh, it's because I'm in radian mode. I was trying to figure out why that came out. It should be -1. Okay, there it goes. -1. So anytime it's 180 or 270 or something like that, -1. All right, cotangent 330. Third quadrant, fourth quadrant, down here, 330 degrees. So that means I got a reference angle of 30. Opposite of 30 is -1. Up here is square root of 3, and my hypotenuse is 2. Now remember, opposite over adjacent. Opposite over adjacent is tangent, so this one's going to be cotangent, which is negative square root of 3 over 1. Doesn't matter where you put the negative. All right, now sine of 240. 240 is in the second quadrant, and that gives me a reference angle of 60. Negative square root of 3, -1, 2. Opposite over hypotenuse. Negative square root of 3 over 2. Now, 45 degrees. I mean, this last one is 135 in the second quadrant, but since it ends in a 5, it's a reference angle of 45 degrees. That means this is the square root of 2. This is negative square root of 2, and hypotenuse is 2. So secant is adjacent over hypotenuse, so that's negative square root of 2 over 2. All right, so if I multiply this all out, I have 4 negatives. If I have 4 negatives, so I know my answer is going to be positive. So whatever it is, my answer is going to be positive. Now if I multiply all the numerators, square root of 3 times the square root of 3 is 3, times the square root of 2. So that's 3 square root of 2. 1 times 2 times 4. There it is, answer. Now, I'm going to check that using my calculator because who knows? I'm tired. I might have gotten it wrong. So, secant 180 times cotangent 330 times sine 240 times secant 135. And I get some weird answer. Notice it's positive, so I know it's positive. So now I'm going to try my answer. 3 square roots of 2 all over 4. Oh, come on. I got it. It's half as much. Why is it half? So oh man, I got my head up my butt. So this is nice. So first of all, I want you to know everybody makes mistakes. I hope most of you were like, what are you doing, crazy man? Because that one's upside down. Remember, secant is the reciprocal of cosine, and cosine would be negative square root of 2 over 2. So secant is negative 2 over the square root of 2. Now my answer is still going to be positive. Let me get rid of some of this stuff. My answer is still going to be positive. Remember, this over 1. So I know my answer is positive. But now, the top is the square root of 3. Square root of 3 times square root of 3, which is just 3. Oh, wait. The square root of 3 times the square root of 3 times 2. So that's going to be 6. Because the square root of 3 times the square root of 3 is 3 times 2 is 6. The bottom is going to be 2 square roots of 2. Notice I already took care of the sign. All right, so 2 goes into 6 3 times. Now I cannot leave the answer like this. So my answer is 3 over the square root of 2. But I can't leave it like this. So I got to multiply by the square root of 2 over the square root of 2. And what I end up with is 3 square roots of 2 over 2. Now, hopefully that's the right answer. 3 square roots of 2, I know it is. divided by 2. And 2.1213. So notice even I made a mistake. Everybody makes a mistake. And I'm tired. That's my excuse. All right. Finally, the half-life. There's going to be a half-life question. Remember, the amount over time is equal to your principal, 1/2, T over H. Now remember, this is the start amount. This is my final amount. This is the time. But this is the most important piece. This is the half-life time. And that's the only hint I'm giving you for that one. You got to use that formula. All right, that's it. Bye.